Hello guys, today we are going to be covering 6.6, which is graphing exponential functions. Excuse me. Okay, so for exponential functions, the equation or the formula for it is y equals a times, and we'll do that with the dot. This is the formula that you see, b raised to the x. This is called an exponential function because the x is in the exponent spot. Okay, exponential functions are defined by an equation of the form. We just wrote that down in the box. Here we'll write it again, a times b to the x. Okay, the important things, if the b is greater than 1, if the b is greater than 1, then the function is an exponential growth. Bigger than 1, that means it's going to be increasing. Kind of makes sense because if it's bigger than 1, it's going up. Now, if the b is between 0 and 1, which means it's a fraction or decimal, then it's going to be an exponential decay. They're called growth or decay, and it is going to be decreasing. Now, we're going to talk about the different characteristics of it, but one of them that we need to make sure that we understand is an asymptote. This is a vocabulary word. It is a line which the graph gets close to, but never touches / crosses. A line which the graph gets close to but never touches or crosses. Now, you're probably like, what's an exponential function even look like? So we're going to look at number 1 together, and we're going to use our handy dandy calculator. So if you don't have it, go get it or pull out your own. So we're going to clear this, and we're going to go to the y equals. We're going to go to the y equals, clear whatever is in the y equals spot. And we're going to type in this exactly right here. 2, we're going to press the number 2, and then we're going to hit the rooftop button because I want to raise it up to the exponent spot. And then I'm going to hit the variable button x so that it looks just like our problem. And then I'm going to hit zoom 6 for standard. And then it's working on it. You can see it. It's getting there. Okay, so when I'm looking at this, you'll notice it does that curve. That is an exponential graph. Okay, it's kind of glary. I'm going to try something real quick. Wrong way. I don't know if that makes it much better. Let me zoom a little bit. See, or there, maybe. Well, that might be the best it's going to get. Okay, so when we're looking at this, yes, it looks like it's touching the y-axis, but it actually is not. Okay, it is not actually touching the y-axis. It just looks like it. And the way we can tell is if we go to our table of values. So see the word table in blue, so that means I press the second button and then table. And I'm going to look at my table. And if I scroll, all these negative numbers, that's the x values. Remember, that's the numbers all on this side of the graph. If I just scroll up, you'll notice that they just keep getting smaller, and they get even to scientific notation numbers. That's because it never actually touches 0. It just keeps getting closer. So we have to, according to our directions, it says to classify as an exponential growth or decay, create a table, graph, We have to classify and then identify its key characteristics. All right. So for the table of values, okay, we're going to always use, for right now, or you're going to be able to always get your numbers from your table, but we're going to use -2, -1, 0, 1, and 2. Those are going to be the X values that we always use because we get to pick whatever X values we want and then plug them in. And we're going to now just look at the table of values to see what they are. And then we just write them down because we're just having to write them. You're getting the information from here. Now, what I could do is plug in these numbers into this X and simplify, but we get to use the calculator. So we have -2 is 0.25. Then we have 0.5, 1, 2, and 4. Okay, so we're going to plot this. Now the decimals are going to be a little bit more difficult to plot. Okay, so here we go. So I'm going to plot 0, 1. Notice that's on the y-axis. And I'm going to plot 1, 2. And I'm going to plot 2, 4. And now my graph, this is not a straight line, so I can't use a ruler. I know it's never going to actually equal. I could do -1 and 0.5. And I really can't do the one that's next to that. So we'll just do this. We're going to draw it right above it. And then we're starting to go up. I know that this is not going to be completely accurate, and that's okay at this point. But you need to make sure that your graph goes all the way through the coordinate plane. So looking at this, this is a growth when I look at it, okay? Because my B, well, I'm going to shift colors at this point, okay? My B is equal to 2. So it is greater than 1, so it is a growth. The domain, remember the domain is all the X values. When I look at this, this continues going in this direction, and it's going to actually continue going out this way continually for forever. So therefore, there are no limits on the X. So the domain is all real numbers. Now, the range, remember the range is the Y values, okay? There is no Y values down here, but there are all of the Y values this direction. So therefore, my range is Y is greater than 0, but it's not greater than or equal to because it never reaches the 0. It never actually equals 0. It never touches the x-axis. So the y-intercept, well, that's right here. This right here is my y-intercept, 0, 1. So it's given to me in my table of values, 0, 1, and it's where it crosses the y-axis. The asymptote is that line where it almost intersects. So this is going to be y equals 0, or they may say the x-axis. You could see either one written as an answer choice. Okay, if you've got questions, pause it, re-watch, or come ask me. Looking at number 2, okay? So again, we're going to type this into our calculator. So I'm going to turn this on. I'm going to go to the y equals. I'm going to clear what's there, and I'm going to type it exactly like I see it. Open parentheses, 1 divided by 4, close parentheses, raised to the x. And then I'm going to graph. So I can see what it looks like. So I'm looking at this. Notice it looks like it's going down. So it's going down, so that should make me think, okay, I'm decreasing, I'm going down, so it should be a decay. That's my first thought. The way we can confirm this is the B is 1/4. That is between 0 and 1, which is supposed to be decay. So we just confirmed that with what our thoughts are. Now we need to get our table of values. So we're going to go to the table. And we are using -2, -1, 0, 1, and 2. I'm going to write those down. So we end up with 16, 4, 1.25, 0.0625. Now I know some of these are not going to be able to be graphed. So we're going to graph the ones that we can. So I'm going to have -1, 4, -2, 16, which will be way over here. So therefore, I'm not going to worry about that one. 0, 1. So I should know right now, oh, I can say that's the y-intercept. Write myself a little note. I can come over here. I can say 0, 1, filled out something. Now I've got 1.25, 1, 0.25. That's going to be like right there. And then 2.0624. So it's coming down this way, but it's actually never going to intersect the x-axis. So, excuse me. There's my graph. It goes all the way through the grid. So my domain is, again, continues in both directions. It never stops. So it is all real numbers. The range is, there's nothing down here, but it's everything up here. So it's going to be y is greater than 0. Never touches the x-axis. So my asymptote is y = 0 or the x-axis. It's really wanting the equation for the axis, which is y = 0, but you could see it say both. Okay, next example. Okay, this is where we're going to start shifting away from the x-axis sum, because we're going to start adding and subtracting information. So that's going to make us shift some. All right. So here we go. Again, first thing I'm looking for, what is my b? My b is 3. So that is greater than 1. So it's a growth. Before I even plug it in, I know that information. Okay. So, and guys, for exponential functions, the domain's always going to be all real numbers unless it's an application problem where you have to think about what makes sense. So this is going to be all real numbers. Now we need to punch in our equation. Y =, we clear this. So I have 3 raised to the x. Now I've got to make sure I arrow out of this so I'm not staying up in the exponent spot when I put -1. Now I want to graph it so I can kind of see what I'm looking at. Notice it is now below the x-axis. Sorry. Okay, and then, so now we're going to fill in. It's below the x-axis, so therefore our asymptote is going to be different. But we're going to get all of this information from our table of values. So I'm going to look at my table, second table, and we're going to notice it's pretty darn close to -1. Look at that, -0.999. Y'all can't see it very well, but there we go. That's pretty darn close to -1, but it is actually never going to reach. Well, it says it does, but it's really not going to. I think that's because the calculator itself is rounding it, because it doesn't actually equal -1. Okay, here we go. So we have plot this way. Oh, I gotta write the table. X, Y, -2, -1, 0, 1, 2. And I'm going to have -2 is 0.889, which is actually rounded. That's what the thing is. It's rounding. So this is -0.8 repeating. This is -0.6 repeating. 0, 1 is at 2, and 2 is at 8. Okay, so now I graph. So I have 0, 0. We have -1 at 0.6 repeating, so that's going to be just a little bit, it's going to be about right there. So therefore our graph, oh, I can graph the other way though. 1 is at 2, and 2 is at 8. 2, 4, 6, 8. So now I can continue. I can do my graph. And it goes up all the way through. Make sure that the graph goes all the way through the coordinate plane. So now I can see, okay, my range is actually going to be nothing down here, but everything that's above this line. This right here is the asymptote. That is the asymptote. Okay, so my range is going to be everything bigger than that. So that's going to be y is greater than -1. There's my y-intercept, 0, 0. The asymptote is y equals 1. What you may be noticing at this point is, wait a minute, that's not 1, that's -1. You should be seeing that the range and the asymptote kind of have some information that's similar. What the asymptote is equal to is also going to be information for your range. All right. Skip down. Let's take a look at number 5. Okay. So with number 5, number 4, it's just changing these two numbers, but it's very similar to 3. Okay. So for number 5, we're punching into the calculator. So we clear what's here. We have our table. So I'm going to actually put this 1/4 in parentheses. Open parentheses, 1 divided by 4, close parentheses, times 2 raised to the x. So we have our table -2, -1, 0, 1, 2. And let's see what we end up with. Let's go to the table. Get table. -2 is 0.0625. Or you could go to the graph first. I probably should have done that first. It's just trying to fill up my table. 0.125. 0 is at 0.25. 1 is at 0.5. 2 is at 1. So now let's see what the graph is. So we graph it. You'll notice it's a little bit further away from the y-axis when we're looking at this. Okay, but when we look at it, it keeps getting closer, and you can see this better if you look at the table. If we scroll up, you'll see that it never really equals 0. Okay, so we have second. Let me go back to the graph so we can make sure we're looking. Okay, so we're going to come over here. And you might be asking yourself, what number is in the B spot? Remember, the formula is y equals a times b to the x. So the b is 2 in this. The a is 1/4. Okay, so we have the 2, which is representing the growth. That it's a growth because it is greater than 1. My domain is all real numbers. And now we're graphing. I'm not going to be able to do that one. I'm not going to be able to do that one. Let's see, 0.25. Oh, we could do that one a little bit, maybe right there. 1.5, 2, 1. And I may actually look at my table of values to find some more accurate. Let's see. Oops, you can't see. I'm going to look to see if I can find some other numbers that might be a little bit more accurate. So I've got 3, 2, 4, 4. What's 5? 5, 8. I can do that. So therefore, my graph is as accurate as possible. Notice those are not on my graph, but I can easily get those points from the calculator, because you do want your graph to be as accurate as possible, especially when we start to predict from it. There's my graph. So we'll notice this is definitely a growth. It is increasing. Okay, my range is everything up here. So it's going to be y is greater than 0. The y-intercept is 0, 0.25. The asymptote is y equals 0. Okay, your assignment is going to be to finish the notes and the classwork homework. Have a great day. If you've got any questions, please make sure you ask.